Enecon Cyber is an energy-saving Hydra cell high-pressure coolant unit from Nikuni. Nikuni's high-pressure coolant unit features a compact design that combines a high-pressure diaphragm pump which can effectively treat sludge with a maintenance-free cyclone separator. The coolant fluid is carried from the fluid tank to the Enecon Cyber system by vortex pump. A cyclone separator removes sludge from the coolant fluid, and the high-pressure pump pressurizes the coolant and injects it from the tip of the machine tool. The coolant delivered to the machine tool clears away chips on the tools and workpieces and functions during high-speed machining to help extend the useful life of tools and improve finishing accuracy, thus raising the productivity of machine shops. With conventional systems, the high-pressure pump spins at a constant speed, making its discharge rate constant. Thus, when the coolant flow rate required by the machine tool is lower than the current discharge rate, surplus coolant fluid is generated and is returned into the tank via the relief valve. This is not an efficient way to use the coolant. By contrast, with the newly developed Enecon Cyber, Nikuni has achieved multi-stage constant pressure control by adding an inverter, a controller, a pressure sensors to the conventional high-pressure pump. The multi-stage control adjusts the pump's output power to ensure that the pump's discharge pressure is equal to the pressure required by the machine tool. Using the multi-stage control, the pump system can deliver the proper amount of coolant to the machine tool, ensuring that no surplus coolant is generated. Further, with the Enecon Cyber system, operators can specify the required pressure when needed, so that they can perform a control operation to relieve the discharge pressure right before complete penetration to a level that prevents cracks from developing in the workpiece, as can happen when drilling a ceramic plate. Further, with the Enecon Cyber system, the frequency can be fixed at a designated pressure. The system allows the user to manipulate the operating parameters, making it possible to deliver the optimum volume of coolant in tune with the operating condition of individual machine tools, workpiece materials, and machining conditions. With conventional systems, the energy contained in the coolant, which is discharged from a vent of the bypass relief valve, leads to a rise in the temperature and requires cooling with an oil cooler. In turn, the heat emitted by the oil cooler into the room raises the room temperature, which has to be cooled by an air conditioner. Ultimately, the resultant waste heat has to be discharged into the environment. This is clearly a double or triple-fold waste of energy. By contrast, the Enecon Cyber system delivers only the required coolant using a high-pressure pump, so its power consumption is curtailed to the necessary minimum. Our system provides an 83% gain in energy saving, for example, when machining a drill hole 4.3 millimeters in diameter. Since the system does not generate excess heat, there is no need for cooling system, leading to substantial energy saving and significant cost reductions. Moreover, the rotation speed of the high-pressure pump can be slowed, greatly reducing the noise emitted by the pump and providing a quieter working environment. Thus, the Enecon Cyber system is a friendly product for both managers and workers. For oil-based coolants, Nikuni has developed fiber with a non-woven fabric filter replacing the cyclone separator. Nikuni's Enecon Cyber system, which allows the operator to set a variety of operating parameters, is a high-pressure coolant unit that offers substantial energy saving and true environmental friendliness.